Welcome to Deep Inside Biosciences. Today we begin part 5 of graph interpretation for life sciences and biotechnology, prepared especially for CSIR UGC Deputy JRF Net aspirants. So let's continue our learning journey. Now let's enter the change family of graphs. In this video, we will study the line chart, which shows how value rises, fall, or remains steady over time or across different stages. Now let's understand what a line chart shows. Imagine watching a tiny plant grow. Its height is 5 centimeters on day 0, 7 centimeters on day 2 and 10 centimeters on day 4. Because the days follow an order, joining this point shows the growth story clearly. Similarly, a line chart can show cells increasing over time or a response changing as the dose rises. The line may rise slowly, rises quickly, remain flat when there is no change, or move downward when the value decreases. So the main idea is simple. A line chart tells the story of ordered change across time or dose. Now let's understand the structure of a line chart. Think of the x-axis as a path whose values must remain in order. It may represent time, age, temperature, concentration, or dose. Here, the order time points are 0, 2, 4, 6, 8, and 10 hours. The graph contains two data series. Blue represents the control and pink represents the drug group. Each group has its own matching point at every time. Connect the blue control points only to other blue points and pink drug points only to other pink points. The control starts near 10 and rises quickly to 100, whereas the drug group starts near 5 and rises slowly to around 30. Never connect points from different groups because that creates an incorrect line. So remember, keep the x values ordered and connect matching points only within the same series. Now let's learn how to read the cell growth graph. The x-axis shows time from 0 to 10 hours with equal intervals of 2 hours. The y-axis shows cell number from 0 to 60 with equal interval of 10. Notice the symbol times 10 to the power of 3. It means every value must be multiplied by 1000. For example, 20 represents 20,000 cells and so on. Next, check the legend. Cyan represents the control group while pink represents the drug group. Both groups begin near 9,000 cells. The control then rises rapidly through approximately 15, 24, 34, 44 and 52,000 cells. The drug group rises slowly through approximately 12, 16, 18, 19 and 20,000 cells. Therefore, over the same 10 hours, the control shows rapid cell growth while the drug group shows much slower growth. That completes our reading of this graph. Now let's understand what it means when a line becomes flat. The drug-treated cell count rises from 9,000 cells at 0 hours to 13,000 at 2 hours, 17,000 at 4 hours and 20,000 at 6 hours. After 6 hours, the line becomes flat, reaching only 21,000 at 8 hours and 22,000 at 10 hours. This flatter region is called a plateau. It is like climbing a steep hill and then reaching a nearly flat top. Here, it does not mean that growth has completely stopped. It means the cell count is increasing much more slowly. The graph shows this slower increase, but it cannot tell us why it happened. Was cell division slower? Did growth stop? Or was survival lower? These causes require further experiments. So remember, the graph shows the pattern while the biological cause needs more evidence. This completes our understanding of a plateau. Now let's understand 6 important things to check while reading a line chart. First is direction. A line may increase, decrease, remain constant or fluctuate. In this graph, both the control and drug lines increases. Second is slope. A steep slope means a faster change, while a gentle slope means a slower change. The control line is steeper, so its cell count increases faster. The drug line becomes gentler after 6 hours, showing that its increase is slowing down. Third is the peak. A completed peak is the highest point followed by a decrease. Here neither line moves downward, so there is no complete peak. Fourth is crossing. Lines cross when they interact and exchange positions. This line begins together at 9,000 cells, but after that they never cross. Fifth is a plateau, where the line becomes almost flat. The drug line begins approaching a plateau after 6 hours, although it still rises slightly. Now read the values. The control moved from 9 to 16, 25, 36, 47 and 55,000 cells. The drug group moves from 9 to 13, 17, 20, 21 and 22,000 cells. Finally, at 10 hours, the control has 55,000 cells and the drug group has 22,000 cells. However, never read only the last point. The complete story is that both increase, but the control increase faster while drug group growth gradually slows. That completes all 6 steps. Now let's focus on an important scientific warning and what are they. Imagine that a scientist measured the value at 4 hours and again at 6 hours but did not measure it at 5 hours. The bright dots represents the actual measured values. The line only connects those dots and guides our eyes. It does not prove what happened between them. From 4 to 6 hours the value might have risen smoothly, risen quickly and then slowly, or even fallen first and then risen. Because there is no measurement at 5 hours, all these paths remain possible. Therefore the 5 hours value is unknown. Never read the middle of the straight line and invent a value. The dashed line shows possible unknown paths, so remember the conclusion. Trust the measured dots, use the line only to see the overall trend, and treat everything between unmeasured points as unknown. Now let's understand 4 common mistakes while reading a line chart. The first mistake is using incorrect x-axis spacing. Values such as 0, 1, 2 and 10 should not be placed at equal distances because the gap from 2 to 10 is much larger. Always use proportional spacing. The second mistake is looking only at the last point. Two lines may finish near similar values but follow completely different path. Therefore compare the whole trend. The third mistake is assuming continuous measurement. The dots are the actual measured points. Connecting lines only guide our eyes and do not prove what happened between those points. The fourth mistake is ignoring error bars. Error bars shows variations or uncertainty. So apparently differences must be interpreted carefully. Error bar appearance alone cannot establish statistical significance. An appropriate statistical test such as a t-test when suitable is required. So avoid these mistakes by checking spacing, reading the whole trend, trusting measured dots and respecting statistical evidence. Now let's understand how line charts are useful in life sciences. First, the enzyme activity graph shows activity rising quickly, reaching a peak, then falling slightly and becoming almost steady. Next, the bacterial growth curve tells us complete story. It begins with a slow lag phase, enters rapid growth, stays nearly constant during the stationary phase, and finally declines. In the drug concentration graph, the concentration rises, reaches its highest point or peak, and then gradually falls over 24 hours. The blood glucose graph shows what happens after insulin is given. Glucose starts above the baseline, falls below it, and then slowly returns close to the baseline. Line charts can also show growth, reaction kinetics, biological rhythm, heart rate changes, population changes, and complete time course experiments. So whenever we want to follow an ordered biological change, a line chart clearly shows the complete story. Its rises, falls, peak, stable phase, or repeating rhythm. This complete life sciences applications of line chart. Now let's answer 6 exam-oriented questions from the line chart. First, which group increases fastest? The control group because its line has the steeper slope. Second, which group approaches a plateau? The drug group after about 6 hours because its value changes only slightly from 20 to 21 and then 22,000 cells. Third, at 10 hours, the control has approximately 55,000 cells while the drug group has approximately 22,000 cells. Fourth, does the drug reduce growth? The graph suggests that cells grow more slowly under the drug condition, but it does not show the biological mechanism behind this effect. Fifth, is the final control point a peak? No, a peak must be followed by a decrease, but no later point is shown. Finally, is the difference statistically significant? We cannot determine this because the graph shows neither error bars nor a statistical test. So in examination, carefully check the slope, complete trend, plateau, values, and statistical evidence. That completes our exam-oriented interpretation. Now before interpreting this line chart, let us complete 4 quick checks. First, identify the variables. The x-axis shows time while the y-axis shows cell count. Second, examine the scale. Both axes begin at 0. Time increases is in equal interval of 6 hours and cell count increases in equal intervals of 2 million. Third, check the units. Time is measured in hours and cell count is measured in millions. Missing these units can completely change our answer. Fourth, read the legend. The blue line represents the control group while the pink line represents the drug group. After completing these checks, we can safely read the trend. The control cell count rises much faster than the drug cell count. So always check the variables, scales, units, and legend first, and only then interpret the trend. That completes our quick check sequence. Now let's begin everything together and understand the complete line chart story. The x-axis shows time in hours while the y-axis shows cell numbers in thousands. According to the legend, blue represents the control group and pink represents the drug group. Both group begins with 9,000 cells. The control then increases rapidly through 16,000, 25,000, 36,000 and 47,000, finally reaching approximately 55,000 cells at 10 hours. Its steep slope shows a faster rate of increase. The drug group rises more slowly through 13,000, 17,000 10,000 and 20,000 cells. After 6 hours, its lines begins to flatten, reaching only 21,000 and then 22,000 cells. Therefore, it approaches a plateau. Neither line forms a complete peak and they do not cross after the starting point. The dots are the actual measured points. The connecting lines guide our eyes, but the exact values between these points are unknown. Therefore, the graph suggests that the drug reduces the rate of cell increase. However, a statistical significance and the biological mechanism remain unknown. So check the axis variables, unit, scale, legend, direction, slope, peak, crossing and plateau, but always read the whole trend. This completes the line chart story. Now let's summarize the 3 key takeaways of a line chart. First, a line chart shows order change. The x-axis may represent time, dose, concentration, age or temperature, but the values must follow a meaningful order. Second, the slope represents the rate of change. A steep line means the value is changing faster, while a gentle line means it is changing more slowly. An upward line shows an increase and a downward line shows a decrease. Third, when two groups such as control and drug are shown, compare them repeatedly at matching time points. Here, the control response rises much faster while the drug response rises slowly. Most importantly, never judge a line chart using only one point. Compare the complete pattern across all points. These are the 3 key takeaways for reading a line chart correctly. With this, we have completed the line chart from the change family. Next week, we will continue our journey by learning about the area chart. Thank you for staying with us until the end of this video. Now let us conclude today's learning with a beautiful and meaningful saying. The beginning of wisdom is this: get wisdom, though it cost all you have, get understanding. This means wisdom and understanding are more valuable than anything else. Learning may require time and effort, but the knowledge we gain is always worth it. This video is also available in Telugu and Hindi. Please like and share this video and subscribe to Deep Inside Biosciences. See you in next video, part 6, where we will learn about the area chart. Till then, stay focused, stay consistent because success is in your DNA. Thank you.